Our learning target is 9.2. We're going to calculate the concentration of a solution. So we need to be able to do these three things. So we're going to compare and contrast strength and concentration, which we did in class. We're going to use the molarity formula, and we're going to learn how to explain how to prepare a solution. So this first bullet is in the PowerPoint notes that I gave you in class. Let's work on these other two. So you should have the examples. So make sure you have those and you're cutting those out and putting them in your notebooks along with your work. So concentration is a measure of how much solute is in a certain volume of solution. We use what we call molarity. So molarity is the moles of solute divided by the liters of solution. So this is total amount of solution, not just the amount of solvent. This formula is in your reference packet. Alright, so our first example. What's the concentration of a solution containing 2.5 moles of hydrochloric acid in 0.250 liters of solution? So we read our problem. We're looking for concentration, which is molarity. Excuse me. We have 2.5 moles and 0.25 liters. That's our volume. Okay? So this is going to disappear when I click the button, just so you know. Alright, so our formula is moles of solute divided by liters of solution. So we have 2.5 moles divided by 0.250 liters, so we just do the division on that, and you get 10 molar HCl. Let's look at our second example now. So here's example 2. What is the molarity, so we're looking for capital M, of a solution that contains 43.2 grams of sodium hydroxide in 250 milliliters of water? So what do I need to solve this problem? I need to convert my grams to moles, because my formula is moles per liter, and I also need to convert my milliliters to liters. Then I can plug all this into the formula. So to convert grams to moles, I'm going to need the molar mass. So 1 mole of my NaOH is 39.998 grams. Alright, so I'm looking for moles. I have 43.2 grams. So I end up with 1.08 moles. Now to change milliliters to liters, you're going to move the decimal point 3 places to the left, okay, 3 to the left. So if my decimal point, change color, is here, 1, 2, 3 places, that is 0.25 liters. So make sure that you do that. You cannot use milliliters in the formula. So molarity is moles divided by liters. So 1.8 moles divided by 0.25 liters, I end up with 4.3 molar NaOH. So if you have grams, you need to convert those to moles, and when you have milliliters, you got to convert that to liters. Alright, here is our next example. Alright, how would you prepare 1 liter of 0.15 molar sodium chloride? Now, when you see this word prepare, you're going to have to write it, your answer in a complete sentence. Okay? So we know that we have 1 liter and we have 0.15 molar sodium chloride. So we need to know how many grams of sodium chloride to use, because my balance will not measure moles. So from my liters and my molarity, I can find moles, and then I can convert that to grams. So if we remember that our formula is molarity equals moles over liters, we can rearrange this to solve for moles. Alright, so we end up with 0.15 equal to x over 1.0, okay, because there's my liters, there's my molarity. So when I solve for x is equal to 0.15 moles. Now I can convert to grams. So I need to know the molar mass of sodium chloride. Alright, so 1 mole is 58.44 grams. So I have 0.15 moles over X. So when I do my math, I end up with 8.77 grams of sodium chloride. Now, I can't just dump 8.77 grams into 1 liter, and we'll find out why in class. We're actually going to see that. So what you're going to have to do is write your answer in a complete sentence. So it should say, mix 8.77 grams of sodium chloride with a small amount of water to dissolve it, and then add the water to total 1 liter. So again, we will see this in class, and how, adding the grams will affect the liters. Alright, so how would we prepare 5 liters of 1.5 molar solution of glucose? It's our next example. So I have 5 liters, 1.5 molar solution of glucose. So I can find my moles using my formula. Alright, so my molarity is 1.5. I'm looking for moles. I have 5.0 liters. Alright, so when I do that math, I get 7.5 moles. Now I have to convert that to grams. So I need my molar mass of my glucose. So C6H12O6, I got to find the mass of that guy. And that is 180.156 grams. Alright, so I know that I have 7.5 moles. That's a lot of moles. Alright, so we're going to get a pretty big answer when we do our math here. So that is 1,351 grams of glucose. So that's how many grams of glucose it's going to take for me to make a 1.5 molar solution of 5 liters of 1.5 molar solution. So when you write your answer, it should look like this. Dissolve 1,351 grams of glucose in enough water to make 5 liters of solution. Now let's look at one final example. This is not a prepare, but that's okay. We add 32 grams of potassium chloride to a container and add enough water to bring the total solution volume to 955 milliliters. What is the molarity? So I know that molarity is moles over liters. So I know that I'm going to have to change grams to moles and milliliters to liters. So let's start with grams to moles. So potassium chloride is KCl. Did that by using the charges and flipping them. Okay, so I'm going to do 1 mole of KCl is 74.55 grams. Remember the molar mass. So that's going to equal X over 32 grams. So I end up with 0.429 moles. Now remember to change your milliliters to liters. Alright, we have 955. Here's my decimal point. Alright, so we move it 1, 2, 3 places. So you end up, I'm trying to do equal sign, with 0.955 liters. So we're going to plug this into our formula. 0.429 moles divided by 0.955 liters. And our answer is going to be 0.5 molar KCl. So just remember to change all grams to moles. When you're preparing a solution, make sure you change moles to grams, because remember that the balances won't measure in moles. Alright, and then plug everything into your formulas and you can solve it that way.